Texan Global School. Addition and subtraction with algebraic fractions. The process is to perform additions and subtractions between algebraic fractions with like and unlike denominators are analyzed. The addition and subtraction between algebraic fractions with like denominators is performed simply by adding or subtracting the numerators of the fractions, and the denominator d goes exactly the same as the denominator of the resulting fraction. Let's look at the first example. We will perform the following operation. As we can see, all the fractions have the same denominator. Therefore, we add and subtract numerators, and the denominator passes precisely the same in the resulting fraction. We then add 14 plus 3 minus 8, obtaining 9, and we divide it by the denominator 5. In example 2, we can see that the denominators of the algebraic fractions are equal. So we repeat the algorithm. We subtract numerators and we divide the result by the same denominator. Hence, we subtract 8x minus 3x, resulting in 5x since they are like terms. This result is divided by 10 since it is the same denominator of the fractions. We can see then that we can simplify the fraction. The numerator has a prime number as a numerical coefficient. However, we separate the denominator into prime factors, 2 times 5. We cancel identical factors, thus obtaining a simplified fraction of x over 2. In this following example, we can see that we have identical denominators. This means that we will add numerators and divide by the same denominator. As it is an addition, the signs are not altered. We group and add like terms, thus obtaining 3y plus 3 over y plus 1. We can simplify this fraction. We obtain a common factor in the numerator, which is 3. The factorization of the numerator remains as 3 times y plus 1. We then cancel identical factors, resulting 3. Before discussing the addition or subtraction between algebraic fractions with unlike denominators, we must remember how to obtain the least common multiple. The least common multiple of a set of numbers is the lowest common multiple between that set of numbers. It is calculated by obtaining, together, the prime factors of each number. Moreover, calculating the product of the common and uncommon factors. Let's look at an example. We will find the least common multiple of 12, 24, and 32. As we can see, we place the numbers horizontally apart. We draw a vertical line. On the right, we write the multiples of these numbers. On the left is the result of the division. At least one of those numbers is divisible by 2, so we write the 2 on the right side. We divide the numbers by this value and write the results on the left side. In this case, 6, 12, and 16. We can divide by 2 again, since at least one number is divisible by this prime number. We write on the right side the 2, and the result of the division on the left side. We have 3, 6, and 8. Once again, at least one number is a multiple of 2. We put the 2 on the right side and write the result of the division on the left side. We can see that 3 is not divisible by 2, so is indicated as is. We thus obtain 3, 3, and 4. We divide by 2 again since at least one number is divisible. We obtain 3, 3, and 2. Again by 2, obtaining 3, 3, and 1. Finally, we divide by 3 resulting 1, 1, and 1. The product of these multiples will be the least common multiple of that set of numbers, which is 96, since it is the smallest number that can be divided by all those numbers. For the case of rational algebraic expressions, we also obtain the least common multiple considering the following. It is calculated with the least common multiple of the numerical coefficients of each term or factor. In the case of variables, the variable with the greatest exponent of all the expressions is selected. Then, the least common multiple will be the product between them. Let's look at an example. We will find the least common multiple of the expressions on the blackboard. First, we obtain the least common multiple of the numerical coefficients 10, 15, and 20. Since at least one of those numbers is divisible by 2, we start with this prime number. The 10 is still divisible, so we put the 2. Subsequently, the 3 is a multiple of 15, and finally, we divide by 5. In this way, the least common multiple of the numerical coefficients of these expressions is 60. In the case of the variables, it will be that with the greatest exponent. In this way, it is x to the fourth. So the least common multiple is 60x to the fourth, since it is the smallest algebraic expression capable of being divided by all the given algebraic expressions. In the following example, we will first obtain the least common multiple of the numerical factors 6, 2, 3, and 1. At least one of those numbers is divisible by 2. Finally, the last multiple is 3. Therefore, the least common multiple of those factors is 6. In the case of the variable x, it will be the one with the greatest exponent. So, it's x cubed. For the next factor, the same concept applies. We will look for identical factors, and the one with the greatest exponent is selected. Therefore, it would be x minus 1 to the fourth. With this, the least common multiple is the product of the previous ones, that is 6x cubed times x minus 1 to the fourth. The addition and subtraction between algebraic fractions with unlike denominators are performed using the addition and subtraction algorithm between arithmetic fractions. That is, the least common multiple is calculated, known as the least common denominator. It is divided by each denominator and multiplied by the numerator. Subsequently, the additions or subtractions of the numerator are performed. Let's look at an example. As we can see, the fractions have different denominators. Then, we calculate the least common denominator of 10, 12, and 6, which, obtaining the multiples, results in 60. We write the least common denominator as the resulting denominator of the resulting fraction. Now we divide 60 by 10, and the result 6 is multiplied by the numerator 3. We repeat the process with the other fractions. We divide 60 by 12, and the result 5 we multiply by the numerator 7. We now divide 60 by 6, and the result 10 we multiply by the numerator 5. We then make the products of the numerator. Finally, we perform the subtraction and addition, thus obtaining a resulting fraction of 3 over 60. This fraction can be reduced to 1/20 since 60 is a multiple of 3. In the following example, we can see that we have unlike denominators. We will calculate the least common denominator. We start with the numerical coefficients 15, 3, and 6. The least common denominator of these numbers is 30. In the case of variables, it will be the one with the greatest exponent. In this case, it is x cubed. Therefore, the least common denominator is 30x cubed. We write the least common denominator as the resulting denominator of the resulting fraction. Now, we divide the 30x cubed by the denominator 15x squared. The result 2x is multiplied by the numerator 1 minus x. Now, we repeat the process for each fraction. We divide the 30x cubed by the denominator 3x cubed. The result 10 is multiplied by the numerator 2x plus 3. We divide the 30x cubed by the last denominator 6x. The result 5x squared is multiplied by the numerator x plus 1. We develop the products of the numerator and simplify like terms. So, results 5x cubed plus 3x squared minus 18x minus 30 all over 30x cubed. In this last example, we also have unlike denominators. However, we must factor the denominators. All cases are trinomial of the form x squared plus b, x plus c. We will look for two numbers that multiplied results the independent term and added the numerical coefficient of the linear term. X squared minus 3x plus 2 is factored as x minus 1 times x minus 2. The next denominator, x squared plus 2x minus 3, is factored as x plus 3 times x minus 1. The last denominator, x squared plus x minus 6, is factored as x plus 3 times x minus 2. Once the denominators have been factored, we obtain the least common denominator. We look for different factors and select those with the greatest exponent. Therefore, the least common denominator is x minus 1 times x minus 2 times x plus 3. We then apply the algorithm to perform the addition or subtraction of fractions. we write the least common denominator as the denominator of the resulting fraction. Next, we divide the least common multiple by the denominator of each fraction. The result of each division is multiplied by each of the numerators of the fraction. We perform the products and simplify like terms. We can see that the resulting fraction can still be simplified. Therefore, we obtain a common factor, which is 4, and we factor as a trinomial of the form x squared plus b, x plus c. We look for two numbers that multiplied results -6 and added +1. Therefore, the factorization of this trinomial is x plus 3 times x minus 2. We cancel identical factors, and we obtain 4 over x minus 1. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com